We are going to start chapter 6 in this lesson. Chapter 6 in pure maths is about trigonometric functions. In this chapter, we're going to look at the reciprocal functions of some new ones. They are still trigonometry. You've learned 3 trigonometric functions so far in GCSE or A level, which are sine, cos or cosine. People say tan or tangent. So sine, cosine, and tangent. We're going to learn 3 new ones, which are also actually related to sine, cosine, and tangent. So you're going to learn what they are. You're going to learn the graph of them, and then you're going to learn some new trick identities with them as well. All right. So 6.1, we'll look at secant, cosecant, and cotangent. The following function, notes the following functions are known as the reciprocal. So you should have learned this word before, reciprocal. Reciprocal means 1 over. So reciprocal trigonometric functions. So cosec x is known as 1 over sine x. So cosec x, the long word is called cosecant. But you can say cosecant x, but we normally just say cosec x. Next one is sec x or secant. Sec x equals 1 over cos x. And you can guess what this cotangent is. Cotangent is, we call it cot. Cot x equals 1 over tan x. There's one more definition about a cot x, because we know tan x, since tan x equals to sine x over cos x, which means it leads to that cot x, which is 1 over tan x. So 1 over means you flip the fraction, will be the same as cos x over sine x. Now this will be useful later on in proof question, because knowing cos x equals cos over sine, we can do some simple simplification and manipulation on sine and cos. Okay, changing cot back to cos and sine. Right, so cosec, I'll just go over again. Cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan. To remember this, you can remember C, if you start the word start from C, is 1 over the other letter S, so they won't be matching. Okay, S and C, cot, you can see T here has to be tangent. This one is usually students don't have trouble remembering. Right, so example, work out the values of A. So bring your calculator out. A, sec 280 degree. Well, we can write sec. There's no sec in a calculator, so what you have to do is you have to do it manually. As sec 280 degree, same as 1 over cos 280 degree. Just put in a calculator, right? And you should get 5.76. So you should try to put in a calculator, see if you get the answer. Okay. There's something weird with the board. The 5 just auto connects each other. 5.76. And B, cot 115 degree. Maybe you can try this one. Cot 115 degree. It's the same as 1 over tan 115 degree. If you put in a calculator, you should get negative 0.466. C, you have learned radians in the previous chapter, so make sure you put your calculator for question C. You see pi over 4 in the question C, means you have to change your calculator into radians mode. So cosec pi over 4, cosec pi over 4, cosec is 1 over sine pi over 4. Put in the calculator, you should get √2. And I'll let you try the last one, D. Okay, put in a calculator, pause the video, have a go at the question D. You should also get √2 as well, because sec is the same as 1 over cos. So 1 over cos, 5 pi over 3, which is √2. Okay, put in a calculator. Right, next one. You have to be able to tell the difference between squared, trigonometric function, reciprocal, and inverse. Now, this table helps you to distinguish them separately, okay? Because down the line, students do get confused which one is which. Squared, when you have sine x squared, that's the same as sine squared x, like this, okay? Same with cos. Cos x squared is the same as cos squared x. And tan x squared is the same as tan squared x. What about reciprocal? We'll just learn it. 1 over sine x equals to, see if you remember it, cosec. 1 over cos is, yes, you're right. Actually, I don't know if you're not right or not. Anyway, is sec x. And 1 over tan x is cot x. Right, inverse. So the inverse, now sine inverse of x. Now, just be careful with this one. Students do mix it up with the squared. If you put a -1 in there, this is not the same, okay? So it's not the same as sine x to the power of -1. So that's not the same, okay? When you put a -1 on top in the sign, it means the inverse. The technical name is called arcsine. So when you have to undo the sign, let's say if you have to figure out the angle, you have to inverse sine in a trig in a SOHCAHTOA question, that's when you use inverse. Inverse of cos is called arccos. We only put one C in there for the arc. It's not ARC and then cos, it's arccos. Arcos. Oh, arcos. Anyway, arctan. Okay, so inverse tan is the same as arctan. All right, so you have to know the difference, especially between the inverse and the squared. The -1 is not the same as putting -1 in the power. Why isn't it the same? Well, why isn't it different? Because if you do that, put a -1 in here, -1 means reciprocal 1 over, and they're not the same, so they're not the same, right? So that's it, 6.2. Next, we're going to learn how to draw the graph of cosec, sec, and cot. To do this, I would suggest you using a pencil, right? So first thing we're going to do, let's say we start with cosec. Why cosec? Because normally we start with sine. Cosec is 1 over sine. So the first one is cosec x graph. Okay, so cosec x graph is the same as 1 over sine x. Remember that, right? So what we're going to do is we're going to start off with the normal axes and the normal sine graph first. So, right, so the sine graph looks like this. So I start from, I think this is probably one of the best sine graph I've drawn. So smooth, 0, the highest point is 1, and then the lowest point is -1. Oh, actually, it's the smoothest curve I've drawn, but actually it shouldn't be drawing too big. So let me try that again. There's a reason for that. So try to make it a bit flatter, but you've got space. So on your notes, so you should be okay. Right, so that's 1, 0, -1. And that angle is pi. Yep, pi over 2, 3 pi over 2, and 2 pi. Now I'm using radians in here because I just want to get students used to using radians as well. You can use 90 degree, 180 degree, 270, and 360. That's not a problem. Now that's a graph of sine x. So this is a graph of sine x. Okay, so y equals sine x. Now what about the graph of cosec? So the graph of cosec, we're going to use a sine x graph to help us draw it. So it will be a reflection of the sine x graph. So take this highest point as your reflection point. Okay, it's going to look like this. And that's the asymptote in there. And there's asymptote in there as well. Right? What about this point? Take the lowest point as your reflection point. And there's an asymptote in there. Okay, so the green graphs is y equal cosec x graph. Right, what about the domain and range? The domain, if you forget what domain and range is, or which one is x, which one is y, think about the alphabetical order of domain and range. The word D and R is the same alphabetical order as x and y. So D comes before R, so as x comes before y. So domain is about x. So what is the domain of the green graph? So x can be anything. If you look across, okay, x can be anything apart from the asymptotes. So x cannot equal to plus or minus pi, plus or minus 2 pi, or we call it plus and minus k pi. K is just number, so 3 pi, 4 pi, 5 pi, 6 pi, whatever. All right, apple pie, cherry pie, cherry pie, ew. R is the range. So what are the y values of the green graph can take? Now you can see the green graph starts from the minimum as 1 for the positive and start from -1 from negative. That means for the range, f of x has either be greater or equals to 1, or f of x has to be less than or equal to -1. Right? So that's the cosec x graph. Next, we're going to do the next one. It's going to be a sec x graph. We know sec x equal 1 over cos x. To draw a sec x graph, we're going to follow suit with the cosec x. We're going to start with the cosine graph. So you can draw your own cosine graph. Cosine graph is a little bit tricky to draw, but as a masterful artist like me, mine is of course the best. That's the cos x graph. 2 pi, and then we've got 3 pi over 2. We've got pi and pi over 2. Right, it's a bit squeezed at the end, but who cares, right? So it's nice, smooth curve like a roller coaster. So that's a y equals cos x graph. 1 and -1. So that's the cos x graph. We're going to use it for our sec x graph. Same thing, we want to look for the highest point and minimum point. That's the highest point. That's the highest point. That's the minimum point. So we're going to reflect this. It's be like this. Okay. And this one will be asymptote. What about the right hand side? Well, okay. So there are 3 parts of the curve. 3 parts in the range between 0 to 2 pi. So that's the green graph is y equal sec x. Right? Now you don't have to remember the graph of cosec and sec x because you can. I would suggest you to do it from a sin x graph and cos x graph. It'll be much easier. Our brain has only so much capacity. You don't have to remember the graph of this. It's easier to derive it from the sin x and cos x graph. Right. So what's our domain and the range? The domain is the x value. So what values of x can we not take? Well, look at the asymptote. We can't take pi over 2. We can't take pi over 2. So the domain is x cannot be plus or minus pi over 2, plus or minus 3 pi over 2, or we can say it cannot be plus or minus k pi over 2. Right. What about the range? Well, the range is going to be the y values. So it has to be greater than 1. So y or f of x has to be greater or equals to 1 or less than or equals to 1, -1, same as the cosec x. Now, for the cot x graph, this one, I'll recommend you to remember it, right? So cot x graph, let's run this out. So, cot x, so cot x is the same as 1 over tan x. It has a similar shape to tan x, but a different way around and a different region. So what we'll do is we're going to start with that's pi and 2 pi. And that will be pi over 2, 3 pi over 2. Asymptote is going to be on pi and 2 pi. And the graph looks like this. So yeah, so that's the graph of cot x graph, like a waterfall falling from 0 to pi and from pi to 2 pi. So cot x is the domain. So x cannot be equaling to pi plus or minus pi plus or minus 2 pi plus or minus k pi. And the range, what about the range? The value of y, we can actually take anything because there's no minimum or maximum of y value. We can take as high as we want, and we can take as minimum as negative as we want. So for the range, we can say f of x belongs to all real numbers. And that will be the graph of cosec x, sec x, and tan x. Right, next we're going to learn how to use some transformation of that one. Part A, sketch a graph of y equals 4 cosec x graph where x is between pi and minus pi. So cosec x is same as 1 over sine x. So the clue is, let's draw a sine x graph first. We want it between minus pi and pi, so be careful, it's not the same as 0 to 2 pi. So we'll just do a sketch, rough sketch on the sine graph. So sine graph from that's to pi, that's to minus pi. So that's from minus pi, and that's pi. So therefore, now that's my sketch, just my draft. Looks like this. Okay, right. So therefore, the graph of y equals 4 cosec x graph. By the way, 4 in front means 4 times. 4 times in transformation, 4f of x is the same as stretching in y by 4. So we're going to multiply the 1 to a 4 and minus 1 to a minus 4. That's a draft. So that's what my graph looks like. So it look like that. That's 4 and that's minus 4. That's the graph. Okay, y and x. So that's the answer. Part B, on the same axis, sketch a line y equals x. So we can sketch a line y equals x. Let me use different color. Let me use y equals x. This. Okay. Right. So how do I know it's not passing through the graphs of the cosec graph? Well, one thing you can do is think of this. When y equals 4, x must equal to 4, right? Because when y equals x means when y is 4, x has to be 4. But we know that minimum point here, this point is pi over 2. This point is pi over 2. So that means pi over 2 in calculator is same as 1 point something, so which is not 4. So that's how we know we are not passing through the graph at all, right? C, state the number of solution to the equation of 4 cosec x minus x equals 0. Now, there must be a reason why they ask you to sketch it in part A, part B. How does that relate to part C? I'll give you some time to think, pause the video, think about how does it relate to part A and part B. The answer is, now if you try to rearrange the minus x to the right-hand side, so question C, if you try to rearrange the minus x to the left-hand side, to the right-hand side, you get this. 4 cosec x equals x. And if you look at the equation of part A, the function of A, 4 cosec x, that's the function from part A. And for part B, y equals x, that's the function of part B. When the equation equals, graphically means we want to find the number of solutions, the number of intersection points. So do they intersect? No, they don't. So any solutions? None. So the answer is no solutions, or you can say 0 solutions, because the graphs don't meet. Right? And that's it. Right, next one. Okay. Practice. I would like to have a go at a question. Sketch the graph of y equals sec 2x minus 1 in the region from 0 to 2 pi. If you struggle with this, I would like you to think of how many transformations are there. So if I say f of x is sec x, so I would like you to draw the graph of sec x first, and then think about how many transformations from here to here. Or actually, the other one, from the sec x to the sec 2x minus 1. Hey, pause the video, have a go at the question. It's all about transformation in here. When you're ready for the answer, you can press play. Right, so this question, there are 2 transformations, the 2x and the minus 1. So first of all, f of x equals sec x means the graph looks like this. So we've got pi over 2, that's 1, and then that's minus 1. So that's pi, right? Yeah, that's 3 pi over 2. No, that's pi over 2. Sorry, pi over 2. That's 3 pi over 2. And then we also have this, which is 2 pi in here. So that's the sec x graph. Next, we've got 2 inside. That means f of 2x, same as sec 2x. F of 2x means we are stretching in x by a half. X is rebellious. Anything affect x will do oppositely. So f of 2x times 2 means times a half, right? So stretch it x by a half. That means we're going to multiply all the x coordinates by a half. So x coordinates by a half means, now using a pencil, the power over 2 becomes power over 4, 3 over 2 pi becomes 3 over 4 pi, and this 2 pi becomes pi. In other words, we've got another cycle going on in here. Okay, that means we have another cycle in there. So this is just a draft. And then last bit, minus 1. Minus 1 means we're moving down by 1. F of 2x minus 1 means we're moving down by 1. Move down by 1. Moving down affects the y coordinates. So all the y coordinates subtract by 1. The 1 becomes a 0, and the minus 1 becomes minus 2. That means the graph will look like something like this. Okay, now this is draft. Okay, draft. So we're going to wrap it up. So the final answer will look like this. Oops. Black. Right. So we start from 0. And it's going to be. There's going to be power over 4. Is it? Yep, power over 4. And then we have a graph section, this time is underneath it. So the second asymptote is then 3 over 4 pi. Okay, next, we then have, oh, this by the way is minus 2, 0. And then we have another one that looks like this. This time is that. So the next one will be pi, 3 pi, so it'll be 5 pi over 4. And then we've got one more here. And the asymptote here, which is 7 pi over 4. And then last but not least, we have this part of the graph touching the 0. And that's 2 pi. Okay, so that is the final answer. Quite tricky, but you have to do it slowly. Even as masterful as I do in graphs, which is not the case, completely opposite. I hate graphs. You just have to do it slowly and just be careful with your answers. So you can see my purple line is my final drafts. That's what I'm thinking. Okay, and that's the end of 6.1, 6.2, an introduction of cosec x, sec x, and cot x. What you've learned is you've learned the definition of cosec, sec, and cot, and you have learned about the difference between square, reciprocal, and inverse. This actually you haven't learned this. You're just sort of recapping. I'm just making sure you don't pick up any misconception from here. And then you've also learned about the graphs of them. All right, they're rare to see in exams, but if it comes up, it will trick you up. So make sure you remember the graph. So you draw the cosec x graph, start from the sine graph, reflect them. So if the sec x graph, draw the cos x graph, reflect it. For the cot x, remember it. Just remember it. Right? And that's it for the lesson.